This picture shows the architecture of a UVM based test bench, and here we are going to see how data is flowing from one component to the component. So for the final aim of the test or the environment is to drive transactions to the DUT, and the transactions are generated from the sequence which is running in a test. So a test will start a sequence, and the sequence will ultimately internally generate transactions, and these transactions should come from the sequence till to the DUT, and the other part is the monitor part where the interface is monitored and transactions are made, and those transactions should go from the monitor till the scoreboard. So we are going to see how this data flow from the sequence to the DUT and from the DUT to the scoreboard is made. So first is the driver transactions, which is generated from a sequence. This is the data flow from the sequence. The transactions will be sent to a sequencer, and from the sequencer it will be sent to a driver, which internally converts the transaction to the pin level DUT. And in order to make this flow happen, the sequencer should get transactions from sequence. So note that there is no direct port connection between a sequencer and a sequence. So the way in which a sequence is started is, sequence will always start on a particular sequencer. So if you go back to the first slide where you are describing the anatomy of a test, you can see that you are starting a particular sequence on a sequencer. You will say that sequence 1.start, and as an argument you will pass the environment.the agent.the sequencer handle. That is, when we call a sequence.start, we are passing the handle of the sequencer on which this particular sequence should start as the argument to the start function. Thus, the sequencer will get the transactions that is generated from the sequence. Now the next part is, from the sequencer, these transactions should flow into the driver. For that, there should be an export in the sequencer and a port in the driver. So if you see this diagram, there has to be an export and port in the sequencer and driver, and they has to be connected together. But the UVM is defining the export in the sequencer and port in the driver in a predefined manner, so that you can just use the predefined names in the sequencer and the driver just to connect them together. So you don't need to define your own port or your own export in the sequencer driver part. Seek item export is a built-in export implementation in the UVM based sequencer, and seek item port is the built-in port in the UVM driver. So you can just use the seek item port dot connect to the seek item export in the agent in the upper class where both sequencer and driver handles are present, which is nothing but the UVM agent. So in your own agent, in the connect phase function, you can see after calling the super.connect phase function, you will be connecting the built-in sequencer export to the built-in sequencer driver. So this is made by the statement driver handle dot seek item port dot connect to the sequencer handle dot seek item export. So the seek item export and the seek item port are predefined variable names in the UVM base class. Now we made a connection between the sequencer and the driver. Thus driver will get this transaction which is sent from the sequencer in its own seek item port. Driver will process this transaction one by one by using this syntax. In the run phase function of the run phase task of the driver, it will wait for a transaction to come into its own sequence item port by using the statement seek item port dot get next item of transaction. So this will wait for the transaction to be sent from the sequence, and when a transaction is available in the sequence item port, it will get in that particular transaction handle in the local variable txn. After that, you can drive the transaction into the DUT by using appropriate protocols, and when the driving is done, you have to send like seek item port dot item done, which will finish this transaction, which will say that the transaction is finished in the driver, and it will release a waiting stage in the sequence. And if at all you need to send a response transactions back to the sequence, you can use the put response function to send back the transaction to the sequence item port. To summarize, these are the connections required to complete the flow of a transaction that is generated in the sequence to get it into the actual driver. In the next session, you will see the data flow of a monitor transactions from the monitor till the scoreboard or any analyzing component.